Good morning. We are going to discuss the Quiz 1 review for Overland Trail. In the first question, you were asked to decide if this should be a discrete or continuous graph. The amount of money collected for pennies for pasta. The key here is that the money is collected at the end of each day. So we do not have a running total throughout the day. So this would be best served as a discrete graph because the money is totaled at the end of the day. Please make sure that you correct any of these questions that you may have missed. And if you'd like further explanation, to reach out to me and I can discuss any questions. On question 2, you're being asked to look at the distance from a child's feet to the ground as they are jumping rope. So my two variables here would be time and distance. And the x-axis would be time, the distance would be your y-axis as dependent, and this could be a continuous graph because time and distance can both be broken down into smaller increments. So your x and y axis, if I take various measurements at different times during this jumping rope, I could though connect all of these dots, and both time and distance can be broken down into smaller parts on the and the data is valid in between the points. New question. On October 1st, you just start saving money for a new TV. The graph provided below is the number of months after October 1st. And so it says, at a quick glance, looking at the graph, it appears that that you are saving the same amount each month because the data is linear. Okay, so because the data is linear, it appears that we're saving the same amount each month. On part B, it says what was done incorrectly when making the graph. So I always check first my scaling to make sure they're consistent. 1, 2, 3, 4, 5, 6, 7 is good. And I'm going up the y-axis, 25, 50, 75, 100, and then 125. But then here, I don't go by 25s anymore. So I have this extra points they've added in. So if I was to remake this graph with appropriate scaling, my graph would not be linear. So the y-axis was not scaled consistently would be appropriate answer for B. Number 4, the graph below shows two families' distance from Fort Hall after or since July 1st. And so we look at the x and the y-axis and kind of analyze the graph a little bit. And on A, it says, which family is closer to Fort Hall on the 1st, and how do you know? So our options here are either family A or family B. And notice here the graph is distance from Fort Hall. So on October 1st, when we start, the family that's closest is going to be this first dot we come to on the y-axis. So we're going to say family A because their line is lower on the y-axis. So remember, we're going to use the terms higher and lower when we're referencing the y-intercept. And then for questions like number 2 here, or on part B, traveling faster, that's going to be looking for families that are steeper. And if you have a question that's saying which one is slower or using more slowly, then you would look for the flatter graph. And here we would say family A again because their line is steeper. If I wanted to know which family was traveling slower, I would say family B because their line is flatter. Let's move on to question 5. Question 5, it was okay if you didn't have graph paper at home to complete the graph, but if you had graph paper, hopefully you were able to make an appropriate graph here. So I have to look at my details for the Spencer family and the Martin family. So looking at your graph, this is what you should have created. And you should have labeled the x and the y axis. So we have hours since 7 a.m. on the x-axis and distance from Topeka on the y-axis. The Spencer family, they start at 100 miles away. At 7 a.m., they're already 100 miles from Topeka. So that means that they got an early start. And they're progressing every hour by 50 miles. So I scaled by 50s on my y-axis. And I went by half hours by skipping every other dot going across or tick mark going across the x-axis. So then I was able to go over 2 spaces and up 1, over 2 spaces and up 1 to get my unit rate plotted correctly. The Martin family, they left Topeka right at 7 a.m., so that means they're at mile marker 0, okay? And they're going 75 miles every hour. They're going at a pretty high rate of speed, and so and again, it's every hour, so I'd go over 2 squares and up a square and a half to get 75, over 2 squares up a square and a half to get 75, and that would continue on the way it is. And then to write an equation for each family, you would want to use those 2 pieces of information given. The starting point and the unit rate times x, and Spencer family is starting point plus unit rate times x. My equations are positive because my lines are increasing, and it's always nice to define your variables. Now here's a little secret for you, those of you that are confused when defining variables. Look at your x and y axis. Anytime you write an equation, it's just your x and y axis is what your variables should be defined when you have a graph with them. Okay, there could be a lot of follow-up questions here on this graph. Hopefully you notice after 4 hours, both families would be at the same location, which is 300 miles away from Topeka. Moving on to question 6. You're saving up for a big purchase. You already have a little bit of money saved up. You are mowing lawns to earn more money. So looking at the graph here, I notice that I have my value on my y-axis. That's my starting point, how much money I have on day 0. So before I've mowed any lawns, I have $20. So that's part A. And then to answer B, how much money do you get paid to mow each lawn? Guys and gals, this is where you need to find 2 perfect corners on your graph. Now, some of these corners are close, but you need to find perfect corners. When we're taking the quiz on the computer, it's very, very important that you find those perfect corners. So it's the vertical change versus your horizontal change. I'm scaling by tens. So my vertical change here is 10, 20, 30, 40, 50 over 4 lawn mows. So 50 divided by 4 is $12.50 each time. And then part C, let's write our equation. Those are our 3 parts that we're really focusing on this quiz. So I'm going to use my starting point plus each amount for each lawn. And again, when you are defining your variables, those variables can come straight from the x and the y axis. That concludes the discussion for this quiz review. Please make sure that you go through prior activities and prepare yourself for the quiz.